Hello, iStar. Hello, community. Thank you very much for inviting me to join this conference. It's a great pleasure and a big honor to give the plenary speech in this event. I'd like to thank Dr. Romel Tabula for inviting me to this conference and to give me such amazing opportunity to share the knowledge across the world. I would like to present our topic today by me, Andrii Kopp, and my colleague, Dmitro Orlovsky. It is about advanced, informative, and understandable data visualization techniques. As usual, we represent National Technical University Kharkiv Polytechnic Institute from city Kharkiv, Ukraine, and the Department of Software Engineering and Management Information Technologies of Computer Science and Software Engineering faculty. This topic is expected to be interesting and relevant for small companies and large corporations, for government institutions and municipal administrations, because they should have permanent access to analytical reports so they can analyze the performance of their organizations and make necessary business or management decisions. That is why information technology solutions, I will call them IT solutions, then these solutions may help managers and analysts to design software applications for data analytics, for data visualization, and the most important part, data-driven decision making, which are in high demand nowadays. So let's first of all get familiar with the data analytics process. It contains 6 steps, each of which deals with the particular data software, and it starts with the data collection, which deals with the databases of some organizational software like HR systems, CRM systems, ERP systems. There could be not only database volumes, there could be Excel spreadsheets, text documents, plain text documents, flat files, and any records stored in computers of some company or institution. Then it comes to data organization, which deals with combining all this data together, depending on their categories, and smoothly went to the data pre-processing, which includes summarization of numerical data, making data transformation then, since not all records may contain proper numbers that can be processed by computers. They may not contain proper string values, which also should be explained to computer how to process them. And then it comes to data modeling, because all the data gathered from so-called raw sources, it should be properly stored, it should be properly structured, so the performance of data analytical operations will be acceptable for fast decision making, for fast insights when some stakeholder gets the data and trying to make some assumptions, make what-if analysis, build some models. If it comes to predictive modeling, it also includes some data forecasting, some machine learning algorithms, and other artificial intelligence technologies. And then it comes to data interpretation, which is the most exciting part, because it deals with data visualization, and this step is what exactly this presentation is devoted to, because we're going to cover, of course, all the steps from data collection to data interpretation, but the most important, the most valuable contribution of our research also includes data interpretation with the help of some visual charts and graphs, with the help of dashboards and reports. So let's also first of all cover the data analytics areas, which are basically two only: descriptive analytics and predictive analytics. However, uh, tasks of descriptive analytics includes a lot of data manipulation algorithms, data manipulation operations, starting from data summarization to data patterns extraction and their visualization to show on charts, on graphs. Whereas predictive analytics focuses mostly on building of prediction models, extraction of prediction models, and applying of these models to new data records to forecast sales, to forecast customer demand, to forecast other things that happen to business and that should be somehow managed. In this presentation, we are going to focus on descriptive analytics and mostly on data summarization and data patterns extraction, but also on visualization of these extracted data patterns. In general, data analytics is the bridge between data warehousing, which deals with databases and special databases, which are called data warehouses, and data analytics bridges databases that can't be used by some managers, by stakeholders, or by other non-technical staff. And it bridges data warehousing to decision making, because managers they need to process data, they need to see ongoing data, historical data, they need to compare data race one and others, and make some assumptions and produce some decisions. This is why data analytics can't exist as its own without data warehousing and decision making. But at the same time, data warehousing became useless without data analytics, and decision making is barely impossible without special data analytics software tools, web services, and even mobile applications. They are now extremely popular in the industry because managers usually work with smartphones and tablet devices rather than traditional desktop computers. And this data-driven decision-making has its own name, business intelligence, or BI. Business intelligence can be understood as umbrella term. It covers reports, scorecards, dashboards, notification alerts, predefined user-specific queries like what-if analysis, some ad hoc queries that may appear from just person's imagination when it uses some data volumes to get necessary insights. Business intelligence also includes multidimensional analysis, statistical analysis, prediction analytics with the help of some machine learning models and algorithms, and of course simulation models to see how decision made on some data may impact on organization's performance in the future when these decisions are implemented on practice. All of these BI capabilities, these BI opportunities, they can help business users, managers, stakeholders, business analysts to make vital business decisions to reduce operational costs of their organizations, companies, or institutions, increase revenues if it's profitable companies, and so on, and make their business more flexible, more scalable, and more manageable, which is the most important in this case. So the special databases that I mentioned before, they are called data warehouses. In simple words, data warehouses can be understood as specialized databases which are used to store records about business transactions, about products sold or purchased, about the customers, about some other performance metrics of the company, about financial results of the company, and other indicators and raw data volumes. This business information can be collected over multiple years, over 5-10 years, in order to be used for analytical purposes, since the more data about how we rule the organization we have, the more opportunities we have to experiment with such data. These data analytical methods and models are using data volumes which are stored in data warehouses to provide statistical analysis, to make predictions, to simulate results and show them to stakeholders. By stakeholders, we understood business users that require such data insights. That can be not only real stakeholders who share some stocks of the company. There could be some managers or their assistants. There could be some branch or regional managers. Any person who is responsible for decisions they made and who needs some strong IT support for such decisions. But more formal definition by data warehouses was given by Bill Inman. A data warehouse or warehouse, how he called such special databases, is a special subject-oriented, integrated, time-variant, and non-volatile collection of data which is used to support management's decision-making process. It's a more dry definition, but it gives all the meaning which I told in this slide in one sentence, which is really great. But besides of data warehousing, the core BI capabilities, the core capabilities of business intelligence are not only data storage using data warehouses and data marts. These are also data extraction. We need to somehow move data from multiple sources, from files, from IT systems, from Excel spreadsheets, from web service logs to data storages. This is why a special pipelines called ETL or extract transform load are used for data transmission from initial raw sources to organized data storages. And the third most important capabilities for human users, not the technical users, are data visualization. That gives an opportunity to build reports and dashboards. So all the data collected in data warehouses and data marts can be visualized and shown to the people so they can understand what is happening now and what they can do to improve the strong sides of the company and reduce or eliminate risks and to reduce the weak spots in the company's performance. I mentioned ETL, extract transform load technology for the purpose, because without this technology, there won't be no data in data warehouses and there will be no visual components in dashboards and reports. It uses data sources as production databases like CRM systems, customer relational management systems, HR systems, human resource systems. ERP systems, enterprise resource planning systems, and other corporate informational system to collect transactional data, to collect all the facts about the organization operations. And it uses special data processing scripts, which are also sorts of software programs that apply some special data summarization algorithms to raw data volumes in order to be capable to store this data into target data sources, which are data warehouses and data marts. But the thing is, I never mentioned what data marts are in compared to data warehouses, to which I gave some simple definition and also the dry definition from Bill Inman. But now let's get into what's the difference between data marts and data warehouses. In fact, data marts are the same data warehouses. They're also relational or wild column databases. They also use dimensional data models to organize their structure. But data marts are different from data warehouses in terms that they are intended to be used in limited domains, in limited subject areas. In example, data mart for sales department can be different from data mart used for marketing department or for procurement department or for human resources department. And usually data marts are built on top of the data warehouses, since they are some special slices of data warehouses that contain only data related to special domain. For example, for sales department, data mart will contain only the data related to sales, but this data will be extracted from data warehouses built for the all enterprise, which in its turn, this data warehouse may gather data from all the enterprise sources, from sales system, from ERP system, if there is production on this manufacturing company, and so on, from HR system to get the data on which employees are responsible for product sales, and so on and so on, from spreadsheets, from text files, from flat files, from all the data sources on the enterprise available for processing and analysis in future. The difference of data warehouse and data mart structures from traditional transactional databases is that they don't use so-called normalization approach. They are mostly built using star schema or snowflake schema with one or several fact tables that are connected to several so-called dimension tables, one and another to produce some facts about ongoing business processes. So in general, the process when some IT specialists like DBAs, database administrators, or database architects, or software engineers creating data warehouses and data marts, this process, this activity is called dimensional modeling process. It includes several steps, exactly 5 steps shown here on this slide. First of all, they need to identify a business process, which people it includes, which IT systems this process includes, and moreover, and most important, which data volumes are created as the result of execution of such business process. After that, they need to identify a level of detail, how deep we are going to analyze data created by this business process, and then identify dimensions. For example, for sales, we can identify in which store, by which sales manager, and which exactly product was sold. And all of these pieces of data together, they create facts which are also appended with some special timestamps when the product was sold, how many items of these products were sold, and by which price this product was sold. And all of these data pieces allow such data warehousing designers to build a schema, as I have shown before, a snowflake schema, or more a simple option and more popular, to be honest, a star schema of the data warehouse or data mart solution. So, for example, the star schema is the simplest, as I already said, but it's extensively used nowadays because of its performance features and simplicity, of course, first of all. And according to the star schema, the ideal star schema, there should be only one fact table at the center and the dimensional tables, which are so-called nodes of this star. For example, like I mentioned, the example with sales facts, we have three dimensions here: customer, to whom the product was sold; product line, which the category of such products; and the city, in which city, in which branch of our supermarket or some retail store these products were sold. And they are all combined, these pieces represented by dimensions, they are all combined together in sales facts, but they are, as you may see, are appended also with unit price and quantity to capture not only categorical databases, but also the numbers that will be in future visualized in dashboards and reports by BI solutions. And this is where data visualization is applied, because dashboards and reports are used at the top so-called presentational layer of the business intelligence architecture. Dashboards and reports help users to visualize data. They can combine plethora of charts, graphs, and other data visualization widgets together in the user-friendly and drag and drop interfaces to get all the necessary insights, to ask IT systems all the questions the answers for they are looking for. And advanced BI tools allow users to visualize results of multiple machine learning models, to classify data, to cluster data, to build regression models, for example, to forecast sales, to forecast procurement, to forecast customer demand, and so on. And all of these machine learning models can be used without coding, barely without coding, in an interactive, graphical, user-friendly interface comparable to Microsoft Excel interface, or comparable to some Google Analytics interface. And this data visualization and reporting tools, they are can be divided simply into two branches of ready-to-use BI solutions, which are usually commerce solutions like Microsoft Power BI, ClickView, and Tableau, and other more solutions, of course, available on market. And there are also other branch of such reporting tools, which are development components like D3, JavaScript library, or Kibana, uh, built over a solution for Elasticsearch stack. But development components are created and supported and utilized by the software engineers who creating custom BI solution. But for small and medium-sized enterprises, but actually for big enterprises as well, ready-made BI solutions such as Microsoft Power BI and ClickView are suitable, and they cover more than these customers have their needs in terms of data querying, data processing, and data visualization. And this previous slide is also can be also proven by Gartner's Magic Quadrant, which they publish every year also for business intelligence platforms. As you may see, leaders are Microsoft, Tableau, and ClickView, and the top leader of business intelligence platforms on market in 2021 is Microsoft with its technology Power BI. And now I'm going to show you the example of sample dataset processing using the Power BI. But first of all, we need some data to process, and we are going to use supermarket sales report. It can be found on Kaggle website. It contains a lot of reports for experimenting with machine learning models, with data visualization, with data processing algorithms, with anything that you need. And it contains, of course, not only data volumes about supermarket sales, but a bunch of data volumes for all the research, all the experiments you can came up with. You can find this data set by your own, also by using the link in the bottom of this slide. So this data report, it contains several columns, and these columns we are going to call them attributes, like invoice ID, branch of supermarket where the sale was processed, city where the supermarket is placed, customer type like golden member, some normal member, gender of the customer, product line like sports for home, health and beauty, electronic accessories, and so on, unit price of each product, quantity purchased by the customer, tax like 5% tax fee for the customer buying, total price, which includes tax also, date of purchase, time of purchase, payment method like cash, credit card, or e-wallet, cost of goods sold in total for the single purchase, gross margin percentage, gross income, and rating given by the customer in the scale from 1 to 10. All of this data, in fact, is presented as the Excel spreadsheet with a bunch of columns, as you may see. And to be honest, this data is extremely hard to perceive by looking to these at least 30 records. But let's see how we can improve this report by using data visualization and data reporting techniques by Microsoft Power BI system. First of all, let's understand the key visualization principles we can use. The most appropriate visualization graphs and charts, which are highly informative and best suitable for human eye, are bar charts. They show comparison in different times, locations, conditions, categories, and so on. Line charts, which are used mostly to display trends over time in some quantitative amounts, sizes, prices, rates, and other indicators. Pie charts, less popular but also attractive visualization tools that can be used to show what parts make up a whole in order to compare relative sizes of these parts. For example, we can use them to divide our data set into types of customers to see which share of golden member customers are different from the share of ordinary supercenter customers. And text cards, they are not so attractive visual components, but they can be used to display single value measures, such as generalized measures, some ratios, performance indicators, or other scalar values in compared to bar, line, and pie charts. By years of extensive research in this direction, we came up with some approach to build proper data visualization models. And the link to our research paper, peer-reviewed research paper, is also placed in the bottom of this slide. But the main idea is shown here in this simple algorithm. first of all, we need to understand, is it time series data or not? If we are dealing with the time series data and we have the data set which is containing more than 12 records, we can use line chart for this. Otherwise, if it's less than 12, or it can be from 10 to 15 actually records, we can use column charts to distinguish different data dimensions. But if we are dealing with the different kind of data, not the time series data, we can check the data set length, and if it's again, of course, and if it's less or equal than 5, then we can use pie chart to show parts of whole data volume in the maybe more attractive for humans, for human eye way, using pie charts. But otherwise, pie chart won't be efficient if we're using more than 5 records in the data set. This is why bar charts are more appropriate in such way. And let's see the examples. For example, we can ask system to process this data set and to calculate the total price, including tax numbers, of purchased products by months. We can process this Excel spreadsheet using the Power BI system, and how exactly data could be loaded into a Power BI system. I shown these examples in my previous presentation a couple months ago, but now let's focus on which particular data graphs we can build and which principles we can use to build these graphs. So it seems that such data is time series data, because we need to group our total prices and summarize them, each of them by months. But there are less than 12 records in such data set, and this is why the column chart will suit the better for our report. And indeed, we obtained this column chart of 3 columns, each of which represents January, February, and March from our historical data presented in the Excel file I shown you before. Another question could be this. What if we need to see the total price, including taxes, of purchased products by days of the last month? In this case, we are going to have at maximum 30 records for each of days in the month of the interested our months. Like, for example, in the previous slide, we had the last one, March, and we assume that we're by the last of months, we are going to have 31 records of purchases for each of the day. And this is why line chart will suit the most, so we can see not the distinguished data, but we can see the trend of purchases and make some ad hoc business decisions to introduce some, for example, sales, to introduce special coupons for customers, to introduce some loyalty program, to increase the sales in the period of next couple of weeks, to maybe introduce sales for trending products, and so on. Another one example, another one question that we may ask to this data set is the total price of purchased products by payment method. And in this case, since we have only 3 methods of payment, cash, e-wallet, and credit card, and the data is not time series data, we can be free to apply pie charts. So now the data is colorful and attractive for people who will analyze this data, but also efficient, since it represents like 3 pieces of the whole number of purchased products. And the last one question I'm going to show in this presentation is the total price of purchased products by product line. Product lines are categories of products like food and beverage, sport, electronic, fashion accessories, and so on and so on. And it seems that we have like 6 product categories or product lines sold in the shopping center. And this data is not time series data. So this is why we need to use bar chart as the alternative to pie chart, since as you may also see, we have more than 5 data categories, which won't be so efficient and informative if we place them in such circle of pie chart. So this is why for better comparison, for better perception of human eye, the bar chart will be more suitable than pie chart. And in total, when we combined all of these questions together and combined all of these data visualizations together on one sheet, we can create this report, or also called dashboard, the special IT solution where all the uh, data visualizations that answer vital business decision questions are combined and placed together in one screen, so the responsible persons can make vital decisions, can lead their company or organization or institution to the success and to compete with other businesses on the rough market nowadays. So this is it for my presentations today. Thank you very much for your attention. Thanks, a lot of thanks to the iStar community, to Dr. Ramel Tabula, who invited me to participate in this great event. Feel free to ask me using this email about this presentation, about other presentations, about possible collaboration opportunities, and so on. Thank you very much, and bye